Hi all. In the last class, we have discussed what is a hyperspace in general case, and we also so that this f is a linear functional from v to f, and f is a non-zero linear functional. Then the null space of f is a hyperspace. Now, using this, we will prove that a characterization for getting G as a linear scalar multiple of f. That means in lemma, in this lemma, we will show that if G is equal to G is identically equal to C times f, if and only if the corresponding null spaces, the null space of f is contained in a null space of G. So this is the characterization for getting G as a constant multiple of f. This G is equal to Cf means G of beta equal to C times beta f of beta for all beta belongs to V. Okay, so if this f is identically 0, this result is trivial. If f is identically 0, consequently we can G is identically 0. If we assume this, then you can easily get null space of f is same as null space of G. That is also same as V. So if f, in the case when f is a 0 functional, when you assume G is equal to Cf, you can get G is equal to 0, then Nf is equal to and G is equal to V, then this inclusion trivially holds. The other way, if we assume Nf is contained in Ng, along with this f is identically 0, we can get this Nf is f. Nf is V, Nf is actually the whole of V. This implies that Ng is also the whole of V, because Nf is contained in Ng. Ng is always a subspace of V as well. So we can get this equality. Then you can easily get this. This Ng is equal to V means this G is a zero functional. So G is identically 0. So once you assume f is identically 0 and Nf is contained in Ng, you can get G is identically 0. Consequently, we can get G is equal to C times f. Okay, so this proves the theorem, or the lemma when f is identically 0. Okay, if f is not identically 0, the immediate consequence is the null space of f, it is denoted by Nf, is a hyperspace of V. In this case, we can write V as the span of the null space of f. This is a hyperspace, so V can be written as the span of Nf union an element alpha which does not belong to this Nf. Okay, so you can find alpha is not in Nf, and you can get V is equal to this. That means the set of all elements of the form gamma, set of all elements beta is equal to gamma plus C alpha, such that this gamma is an element of Nf and C belongs to the corresponding fields. So this is the implication of a non-zero linear functionals, and we will prove that G is equal to Cf identically if and only if Nf is contained in Ng. Okay, so first you assume Nf is contained in Ng. Okay, we will prove that this G is equal to Cf identically. G is identically equal to Cf. So if an Nf is contained in Ng, along this f is a non-zero linear functional, there exists alpha belongs to V such that f of alpha is non-zero. Because f is non-zero, then you can find alpha belongs to V such that f alpha not equal to 0. So it is enough to choose this alpha to represent this V, or to get the V as beta set of all beta is equal to gamma plus C alpha. Okay, so once you assume f is not equal to 0, you can easily find alpha belongs to V such that f alpha not equal to 0. What is the consequence of this? F alpha not equal to 0 means alpha is not in NF. So if you choose any alpha not in NF, the span of NF union alpha is always V, because NF is a hyperspace. So using this idea, if you choose any alpha from outside of this NF, then this V can be written as, every element of V can be written as gamma plus C alpha, where gamma is in NF and C belongs to F. Okay. From this you can easily prove that G is a scalar multiple of F. For that we define a new function h is equal to G minus Cf, and we will prove that this h is identically 0. Okay, so first we evaluate what is h gamma or h beta. That's the thing. H beta can be written as h of gamma plus c times h of alpha. So it is in order to prove h of beta is equal to 0 for all beta belongs to V, it is enough to show that h of gamma equal to 0 for all gamma belongs to NF, and h of alpha equal to 0 for this alpha and C belongs to F. So it remains to show that h of gamma equal to 0 for any gamma, h of alpha equal to 0. So that is enough to get this h is a 0 function. For that, first evaluate h of alpha, that is trivial thing. Before that, we need to define the C. We'll define h as G minus Cf, where C is equal to G of alpha divided by f of alpha. So this is defined because this f alpha is non-zero. So G alpha and f alpha are scalars, then G alpha by f alpha is defined. So using this C, we define this expression. Okay, so it is very easy to show that what is h of alpha. H of alpha is equal to G of alpha minus C times f of alpha. So that is G alpha minus, what is C here? C is G alpha by f alpha. So that doesn't depend on this beta anyway. Okay, so this h alpha is equal to this is G alpha by f alpha times f alpha. Then you can cancel this, you can get this is equal to 0. So we can show that this h alpha is always 0. Now you evaluate h gamma. Okay, an arbitrary element from n alpha. So our assumption is this gamma is an element of NF, but we know that NF is contained in NG. So from this you can say that f gamma is equal to 0 as well as g gamma is equal to 0. So this is g gamma minus c times f of gamma. Since this gamma comes from this NF, then f gamma is 0. G gamma is also 0 because NF is contained in NG. So gamma is contained in NG. So this is 0 minus c times 0, that is equal to 0. So you can say that h of alpha equal to 0 and h of gamma equal to 0 for all gamma. Therefore, this h of beta equal to 0 for all beta belongs to V, which shows that this h is a 0 functional. Consequently, you can get G minus Cf is identically equal to 0. Okay, that means G is identically equal to that Cf. Okay, so that is G is constant multiple of F. So whenever we assume NF is contained in NG, then you can get this G minus or G is equal to that C times F. So this would imply this thing. Okay. The converse is trivial. Whenever G is equal to C times F, G is identically equal to C times F. This means G of any beta can be written as C times F of beta for all beta belongs to V. Okay, so we assume this an element gamma from NF implies that F of gamma equal to 0, implies G of gamma equal to C times F of gamma, that is C times 0, that is equal to 0. This implies G of gamma is 0, that implies gamma belongs to NG. So whenever gamma belongs to NF, then gamma belongs to NG. This shows that NF is contained in NG. Okay, so this proves lemma. Whenever NF is contained in NG, if and only if G is equal to CF. Okay. Now we will consider the general case in the next class.